Today, we're going to work on angles and arcs from intersecting stuff on a circle. This is good. Okay, Innies and Outies for your assignment. All right, going to use this, and feel free to stop and think about these as you want here. On any of these circles, the X is in red, the Y is in blue. Okay, so this is circle M. Okay, talking about this first row here. Circle M. This angle right here is 60 degrees. I put it right over here for you. Okay, well, if the red is 80 and the blue is 40, okay, I'm going to put these up here for you in this table. And what we're trying to look for is relationships. Okay, and if the red is 80, okay, that's 80 degrees. Okay, and then the blue is 40 degrees. If I take the x plus the y, I get 120 degrees. If I take the x minus the y, I get 40 degrees. And what I want you to look for is there a relationship between this number and angle 1 or this number and angle 1? Okay? Just going to let you think about that for a second. Okay, now we're back. Now we're down here on number 2. Okay, so the x is 100, the y is 30, and angle 1 is 35 degrees. So I'm going to go, so the x is 100. Okay, the y was 30. Okay, if I add the x and y, I get 130. If I subtract the x and y, I get 70. Now, is there a relationship between this and angle 1? Or is there a relationship between the 70 and angle 1? I'll let you think about that again. Okay, the x in this one, 150. The y is 60, and angle 1 is 45 degrees. Okay, so the x is 150. The y is 60. Now if I add the x and y, that's 210 degrees. Now is there a relationship between the 210 degrees and the 45? Well, 150 minus 60, that would be 90 degrees. Is there a relationship between the 90 degrees and the 45? I wonder. Okay, let's try one more. The x is 200, the y is 160, angle 1 is 20. So this is 200, and the y we said is 160. So if I add those, that's 360. Is there a relationship between 360 and the 20? What about 200 minus 160? That would be 40 degrees. Is there a relationship between the 40 and the 20? Okay, here's what you should have found. In this first one, now notice where the intersecting lines are. Okay, these intersecting chords right here are inside the circle. Now look at what the relationship is. It's not this one that has the relationship, it's this first one. Because if I take the 120 divided by 2, that's 60. Okay? Now, let's look at the next one. Is it the 130 or the 70 that has the relationship with the 35? It's the 70, because if I take 70 divided by 2, that's 35. Is it the 210 or the 90 that has the relationship with the 45? It's the 90. Is it the 360 or the 40 that has the relationship of the 20? It's the 40. Well, what's different between these last three here, and this first one? Well, look at where the intersection is. Okay, this is two secants that intersect. Secants, perhaps you might remember that term, secants. Well, they add or they subtract and divide by 2. Now, I don't care what happens out here or out here. Okay, it's what's inside the intersecting secants. Okay, same thing here. I don't care what's happening here, but if I take the 150 and the 60 and I subtract them and divide by 2, I get this 45. And if I take the 200 and the 160 and subtract them, 200 minus 160, but I divide by 2, I get that. So patterns. Patterns. We don't just make stuff up. We find patterns. We call these the belly button theorems. You're welcome. Little smile for you. Yikes. Okay. We call them the belly button theorems because we have the innies and we have the outies. Okay. The innies, yeah, the innies, they intersect. Yeah, I think that's a comb. I'm not sure. Okay. Yikes. Yikes. Okay. The innies, they intersect inside the circle, and the outies intersect outside the circle. Belly button theorems. You're welcome. Okay. Rap sheet. This means reason and proof. It's not a no, it's not a rap sheet. It's reason and proofs. Okay, so if they intersect inside the arc, okay, so they intersect inside the arc, then we add the two together and divide by 2. Okay, remember that goes back to this first one. They intersect inside the circle, we add them together and divide by 2. Okay, so if we add together and divide by 2, the relationship, this is an innie, okay, you add those in red and in blue, divide it by 2, and you're always going to get that one right there. And if you said, well, what about the other side? Well, the other side's the same because you're right, vertical angles. God, we learned a lot this year. Okay, next one, outies. Okay, now, the outies, we have 2 secants or 2 tangents or a secant and a tangent. Okay, and it doesn't matter what's what. It's where they intersect. Okay, all 3 of these intersect outside the circle. Outside, outside, outside. This is an outie. Okay, so what's in between the 2 intersecting parts? 2 secants, 2 tangents, secant and tangent. Okay, I don't care what's here. I don't care what's here. I care what's in between the 2. I subtract them and divide by 2. X minus y divided by 2. That's going to get me angle 1. Same thing here. This is going to be x minus y divided by 2. That's going to get me angle 1. And again, I don't care what's happening out here. That's totally irrelevant right now. It'll help you later. X minus y divided by 2. That's going to be angle 1. Outies. So we have the innies and the outies. Feel free to watch this stuff again. Okay, and this you're going to have to know also. Okay, so real quick, if this part right here of the circle is x, okay, then what's the value of the rest of this circle? Yeah, you're right. If the total circle is 360 and what's in the green is x, then the rest of this circle must be 360 minus x. This is going to be important at the end of this lesson. Make sure you try all the problems all the way through. The worksheet's at the end. Innies and outies, you're welcome.